Hello guys, welcome back to my channel. Please remember to like and subscribe. Now today we're going to be looking at integration involving basic trigonometrical identities. So without further ado, let's get right into it. Now we're going to start with the integral of 1 over sec x dx. Now, in a scenario like this, when I examine the function 1 over sec x, I do recall that from my previous videos, I wouldn't have given you an integral for 1 over sec x. I would have given you an integral for sec squared x. And we know the integral of sec squared x is tan x. But what about sec x? Since we don't know the integral of 1 over sec x, we're going to have to associate sec x with an identity that we know, are associated with a function that we can integrate. So we can go right ahead and we can say, recall that 1 over sec x is equivalent to cos x. So the integral of 1 over sec x would really imply the integral of cos x with respect to x. And we know from our previous video that when we integrate cos x, we're going to get sin x plus the constant of integration, which is c. Similarly, if I wanted to find the integral of 1 over cosec x with respect to x, I would apply a similar identity. So I'm going to say, recall that 1 over cosec x is equivalent to sin x. So this would imply the integral of sin x with respect to x. And let us recall from my previous video, when I integrate sin x, what do I get? I'm going to end up with negative cos x plus the constant of integration. All right, next we could look at the integral of tan squared x. Now, the problem here is the tan square. However, we know that tan squared x is connected to a ratio, which is sec squared x, that we know how to integrate. And so that is how we apply the integral. So we're going to recall, so we could recall that 1 plus tan squared x is equivalent to sec squared x, which means that we can actually transpose this identity for tan squared x. So we could say that tan squared x is equivalent to sec squared x minus 1. So it means now that the integral is going to become the integral of sec squared x minus 1 dx. We know that when we integrate sec squared x, we get tan x, and when we integrate 1, we get x. And don't forget your constant of integration, so we have plus c. The next trigonometrical function that we would like to look at is the integral of cos squared x dx with respect to x. Alright, we know how to integrate cos x. The problem we are having here is the power, cos squared x. However, we know that cos squared x is connected to a ratio that we can easily integrate. Now recall your double angle formulas, and I have those in my trig videos. We know that, so let me go here and say, recall that cos 2x is equivalent to 2 cos squared x minus 1, which means that I can transpose this identity for cos squared x. So we could say cos 2x plus 1 is equal to 2 cos squared x, which would imply that cos squared x is equal to a half cos 2x plus 1. Or we can just put cos 2x plus 1 over 2. It means the same thing. The integral now becomes, and of course, because the half is multiplying the bracket, the half can go outside of the integral. So we have cos 2x plus 1 dx. Alright, we're quite in a comfortable state now. Now when I integrate cos 2, so I'm going to have my half outside, which is unaffected. When I integrate cos 2x, I'm going to end up with sine 2x over 2. And when I integrate 1, I'm going to have plus x. And of course, we add our constant of integration. Now, we're not going to leave the function like this. We're going to tidy it up. So this becomes a quarter sine 2x plus a half x plus c. And that is how we integrate cos squared x. Of course, integrating sine squared x would take a similar approach. Now, integrating sine squared x would take a similar approach as that of cos squared x. So let's go right ahead and recall. Now, we can recall that cos 2x is equivalent to 1 minus 2 sine squared x. And of course, since we're interested in integrating sine squared x, we need to transpose this for sine squared x. So probably we could bring over the 2 sine squared x. So we have 2 sine squared x. We bring over the cos 2x is equal to 1 minus cos 2x. So sine squared x would be equal to a half into 1 minus cos 2x. So this would imply the integral, and bear in mind a half is a constant multiplying the function, the half can go outside. So we have 1 minus cos 2x dx. Now when I integrate what is inside of the bracket, I integrate 1, I get x. When I integrate cos 2x, I'm going to have minus sine 2x over 2. And of course, we add the constant of integration. Now, if I were to expand this bracket, I would end up with a half x minus a quarter sine 2x plus a constant of integration, which is c.